Hi, and welcome to the Learning Zone. I'm Mr. B. After watching this lesson, you will be able to determine the displacement of an object that is moving with constant velocity. Let's begin the lesson with a brief review of vocabulary. Displacement, delta x, is equal to the final position of an object minus its initial position, or delta x is equal to x sub f minus x sub I. Average velocity is equal to the object's displacement divided by the change in time, delta x divided by delta t. Or, average velocity may be calculated by adding the initial velocity plus the final velocity and dividing by 2. Average acceleration is equal to delta v divided by delta t. It is possible to use the two equations for average velocity to determine the equation for displacement. Consider the following. Average velocity is equal to delta x divided by delta t, where delta x is equal to the change in position of an object. For an object moving with constant velocity, average velocity is also equal to v sub I plus v sub f divided by 2. To find an expression for displacement in terms of initial and final velocity, set the expressions equal to each other. Average velocity is equal to delta x divided by delta t, which is equal to v sub I plus v sub f divided by 2. Multiplying both sides of the equation by delta t leaves us with an expression for displacement as a function of time. Delta x is equal to v sub I plus v sub f divided by 2 times delta t. And simplifying the equation, delta x is equal to 1/2 times v sub I plus v sub f times delta t. This equation can be used to find the displacement for any object that is moving with constant velocity. Before applying the displacement equation to an actual practice problem, a couple of important points should be made. First, displacement, acceleration, and velocity are examples of vector quantities, where a vector quantity possesses both magnitude and direction. Time and mass are examples of scalar quantities. Scalar quantities possess magnitude, but no direction. Now let's apply the displacement equation to an actual practice problem. Consider the following. A motorcycle reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its braking system. If the motorcycle comes to rest 5.5 seconds later, how far did the motorcycle move while stopping? This is a graph of the actual event. Notice that the line has a negative slope. A negative slope means that the motorcycle is actually decelerating or slowing down. From the information we're given that the initial velocity is 42 meters per second and the final velocity is 0.0 seconds, while delta t will be 5.5 seconds. From the equation where delta x is equal to 1/2 times v sub I plus v sub f times delta t, we may now insert the information. Delta x is equal to 1/2 times 42 meters per second plus 0.0 meters per second times 5.5 seconds. Simplifying the equation yields the following. Delta x is equal to 1/2 times 42 meters per second times 5.5 seconds. Clearly the seconds will cancel and the answer will be delta x is equal to 15.5 meters, or using the proper number of significant figures, which are 2, the final answer should be 120 meters. Now let's apply what we have learned to an actual Regents practice problem. Consider the following. Base your answers to the following questions on the graph below, which represents the relationship between velocity and time for a car moving along a straight line. The first question asks us to determine the magnitude of the average velocity of the car from 6 seconds to 10 seconds. According to the graph, the car is accelerating at a constant rate from 0 seconds to 6 seconds, reaching a final velocity of 15 meters per second. Then the line plateaus from 6 seconds to 10 seconds, indicating that there is no change in velocity. Therefore, the average velocity of the car from 6 seconds to 10 seconds will be 15 meters per second. We're now asked to determine the magnitude of the car's acceleration during the first 6 seconds. Average acceleration is equal to the final velocity minus the initial velocity divided by the final time minus the initial time, or delta V divided by delta T. The final velocity was 15 meters per second, and the initial velocity was 0 meters per second. The final time was 6.0 seconds, and the initial time was 0 seconds. 15 meters per second divided by 6.0 seconds will equal 2.5 meters per second squared. And finally, we're asked to identify the physical quantity represented by the shaded area on the graph. On a graph of velocity versus time, the shaded area will represent displacement or distance traveled. This concludes my explanation of how to determine the displacement of an object that is moving with constant velocity. Hopefully this video has been helpful. Thanks for watching.